All right, here are solutions to perfect problem. What are we up to here? 8 for math 65. We're doing a bunch of, I guess a bunch of factoring, basically. We're going to try to solve these equations, and we'll do so by using all the factoring tricks we've learned. So in this first one, first of all, when you're trying to solve an equation by factoring, it will only help if we have it equal to 0. So in this case, we have it equal to 27, not 0. So we want to change that equation. We want to subtract 2 or subtract 27 from both sides of that equation, because by doing so, we'll have an equation equal to 0. And then we can factor, and it'll help us figure out what the solutions are. So okay, to factor this thing, first look for a greatest common factor. There is none in this case. So then what we want to do is find two numbers. Maybe I'll write that here. Find two numbers that we need them to add to whatever the coefficient of the middle term here is, negative 15, and multiply to the product of the first and last coefficients, the 2 and the negative 27. So if you multiply those two numbers together, you get negative 54. So what we got to do is find two numbers that add to negative 15 and multiply to negative 54. And you can do that by finding all the numbers that multiply to 54. Let's see, 1 and 54 would work. 2 and 27 would work. 3 and 18 would work. And we could keep making this list, although I think we've already found the one we want. Let's see, if they're going to add to negative, if they're going to multiply to a negative number, one has to be negative, one has to be positive. So taking one of these sets, making one negative, I think this third group here, if we make the 18 negative, if we say negative 18 and positive 3, what we've done is we've finished step 1. We found two numbers that add to negative 18 and multiply to negative 54. And that's just one step in the process. Step 2, we'll replace negative 15x with negative 18x and positive 3x. So we'll take those two numbers we just found and replace the middle term with them. And we still haven't factored, but what we've done is changed it from a problem that has 3 terms into one that has 4 terms. It turns out one with 4 terms is easier to do. We can factor by grouping here. So if we take the first two terms, the 2x squared and the negative 18x, and find their greatest common factor, in this case it's 2x, and factor that out, we'll be left with x minus 9. And then look at these next two and find something that we can factor out from these next two so that we'll be left with x minus 9. In this case it's a positive 3. And now what we have are two terms and they both have an x minus 9 in them. So we can factor out that x minus 9 and get x minus 9 times 2x plus 3 equals 0. So what that tells us is either x minus 9 equals 0 or 2x plus 3 equals 0. So either x equals 9 or 2x equals negative 3, and therefore x equals negative 3/2. So we get two solutions here, x equals 9 and x equals negative 3/2. I told you to check these. Ugh, I don't really want to, but I guess I should. We can take either of these numbers and plug them back in for x. We can do 2 times 9 squared minus 15 times 9 minus 27, and make sure that that does in fact equal 0. 9 squared is 81, and 2 times 81 is 162. 15 times 9, well 15 times 10 is 150. One less would be 135. So we subtract 135 and subtract 27. And I think in fact we would get 0 here. 135 minus 27 more is 162. So it looks like x equals 9 really did work. We didn't screw anything up. How many of these do I have to do? Oh, 4 of them. Okay, maybe I'm going to change these problems. And if you want, So, okay, what I'm going to do, I'm going to change these problems and say you only have to check one of them. So I'm going to make it so you don't have to check all 4 of these, just check one. So I'm going to check my answers to number 1 here since I've already started doing it. But I don't want you to have to spend forever on these problems. So I'm going to change the instructions. Check our other answer, negative 3 halves. 2 times negative 3 halves squared minus 15 times negative 3 halves is supposed to equal minus 27 is supposed to equal 0. Negative 3 halves squared is positive 9/4. So 2 times 9/4 minus 15 times negative 3 halves minus 27 is supposed to be 0. Well, 2 times 9/4 is, we could think about this as 2 over 1 and cancel out this 2 with one of the 2's over here. What I'm trying to say is you're left with 9/2 here. Let's see, the 2 negatives will cancel out if you think about this as 15 over 1. So we get plus, and 15 times 3 is 45 halves. I'm a little low on room here, but if we took this one more step, 9 plus 45 is 54. So you get 54 halves minus 27 equals 0. And in fact, it does. This is 27. 27 minus 27, sure enough, is 0. Cool. Looks like our answers work. All right, now let's do the rest of these without checking them because this video is already getting long. Maybe I'll do them a little quicker. Number 2, solve this mess. Okay, we can't solve this mess because it's not equal to 0. So what we'll do, our trick will be to FOIL these 2 out to multiply 2x plus 1 and x minus 3. Use this box method we got here. 2x times x is 2x squared. X times 1 is 1x. Negative 3 times 2x is negative 6x, and negative 3 times 1 is negative 3. So really what question 2 is saying is 2x squared minus 5x. I get minus 6 and plus 1. Minus 3 equals negative 6. So I could set it equal to 0 by adding 3 to both sides. I get 2x squared minus 5x plus 3 equals 0. And then I can follow this method over here, find 2 numbers that add to negative 5 and multiply to positive 6. I think negative 3 and negative 2 are the numbers. Okay. And so replace negative 5x with negative 3x and negative 2x. And then factor by grouping. These first 2 guys have an x in common, and that'll leave me with 2x minus 3. And to be left with 2x minus 3 here, I'd have to factor out a negative 1. So if we factor out the 2x minus 3, we're left with x minus 1 equals 0. So what that tells us is either 2x minus 3 equals 0 or x minus 1 equals 0. So either 2x equals 3 and therefore x equals 3 halves, or x equals 1. All right, third one. Man, I made this problem too long. Oh well, nothing I can do now. Well, that's not true. Nothing I'm gonna do now. Number 3, okay, kind of similar to number 2, except now we have pairs of things on both sides of the equation. So we're going to have to multiply 2x plus 1 times x minus 4. All right, I'll write it out. 2x plus 1, x minus 4. That gives us 2x squared plus x minus 8x minus 4. In other words, 2x squared minus 7x minus 4, because we had negative 8x and plus x. And then I have that is equal to, I'm going to need another one of these boxes. Maybe I can stash it over here to figure out what x minus 3 times x plus 2 is equal to. You might be able to do this without the box, but to show my work, I'll do it over here. We get an x squared, we get a minus 3x, we get a plus 2x, and we get a minus 6. So we get x squared minus x minus 6. So really what this equation is telling me is that equals x squared minus x minus 6 minus 6. This additional minus 6 right here. And so what I want to do is get this equal to 0. And I can make this equal to 0 if I first combine like terms and then move everything over to one side. So subtract x squared from both sides. 2x squared minus x squared just leaves me with x squared. Add x to both sides. Negative 7x plus x would be negative 6x. And then add 12 to both sides. Negative 4 plus 12 would be positive 8. So what I've managed to do is write the original problem as this equation right here. And to solve this equation, I just need to find two numbers that multiply to positive 8 and add to negative 6. Those numbers are negative 4 and negative 2. So what I get is that either x minus 4 equals 0 or x minus 2 equals 0. And so I get either x equals 4 or x equals 2. And finally, the last one, x cubed plus 3x squared what else was in there? Minus 4x equals 12. Okay, same strategy as we've been using. First we want to set it equal to 0. Then look for a greatest common factor. There are none. Then recognize that we have 4 terms, so we're going to factor by grouping. Pull out an x squared from the first 2 and be left with x plus 3. Pull out a negative 4 from the next 2 so that we'll be left with x plus 3. And now we have 2 terms that both have an x plus 3 in them. So factor that out, and you're left with x squared minus 4. But we're actually not done here because this will factor further. X squared minus 4 is a difference of squares. So we get it's x plus 2 times x minus 2. So now we have things completely factored. We can say, all right, either x plus 3 equals 0, x plus 2 equals 0, or x minus 2 equals 0. That is, either x is negative 3, x is negative 2, or x is positive 2. Whew, so those are the answers, and that's finally the end of this problem.